geometry? Look at that. I'm pretty skinny, huh? How do you think I got out of that door? That's some amazing camera work there. so, sorry, I thought that would look better than it did. I guess it would help if my hinges were on the same side of the doors. Um, okay, so let's stop goofing around. And let me tell you, chapter 10 is going to be a treat after chapter 9, okay? Chapter 10 is all about area. And you know that area, well, first of all, we have a polygon. You know that the perimeter is the length around it, but the area is all the space that it takes up. Okay? In fact, that's your first postulate, area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. So, for instance, if I took this and I divided it in two, the area of the whole thing is the area of this triangle plus the area of that triangle, okay? Which I think you can just see. Okay, we're going to do two things today, parallelograms and triangles, and they're both cinchy as heck. So you got a parallelogram, and if you know that these are parallel and these are parallel, then if you look at it close, you could actually cut off that and slide it on over here and add it in right there. And if you did that, you just have, well, I know I'm a little messed up there, but you just have a simple rectangle, okay? So a parallelogram is really just a rectangle just kind of smooshed over. You know that the area of a rectangle is the base times the height, or usually we say length times width. So for a parallelogram, the area is going to be the same thing. It's going to be the base, but this time it's not this length here, it's the height. So it has to be perpendicular. So area of a parallelogram is base times height. And remember that whenever you have units, if it's the units for a perimeter, that's just a simple length. So if it was in meters, you just have so many meters. But if you have area in meters, it's two things being multiplied. It's meters times meters. So this is always going to be expressed as some unit squared. Okay? All right. Okay, let's continue on. If we have a triangle, I know that you know this already. The area of a triangle is the base here times the height again, but it's 1/2 of that. So you can write this different ways. 1/2 base times height. Or you could write it base times height divided by 2. That's the same thing. And it doesn't matter what side you use. You could do the height from, you could have this be the base and this be the height, or whatever, you know, it's all going to be the same. Which brings us to the last little thing, and it's postulate 10-2. It says if two figures are congruent, they have the same area. So it doesn't matter which way I measure this, or if I had another triangle that was the same exact thing. Does that look similar? I think so. So if these two are congruent, they're going to have the same area. Okay, that's it. That is about as easy as heck. Go back to wondering how I got out of that small closet. Okay.